Okay, so the major area which we're going to talk mainly is the part which you generally find difficult. So for example, what is difference between permutation combination, what is the counting principles, and of course we're going to take plenty of examples. Now generally when I see students struggling is on the area of like how do I differentiate which one is permutation, which one is combination. I'll try to generalize certain what I can say is prerequisites where your basic you can apply that. Okay, this is particular area where you see permutation, there is particular area that is called combination. Okay, now before we start with permutation or combination, which what we need to have is a clear idea or picture of what exactly is factorial notation. Okay, so what I'm going to show is, let's say if I have factorial. Now, when I'm talking about 5 factorial, it basically means that if you have random 5 different objects, so if you've got 5 different objects, and suppose that you're placing them in a particular place in a row, the moment you're going to pick the first one, you'll have 5 choices. You can pick up any one from here and place them. So the moment you're about to place it, you have 5 choices. Now, suppose I have placed one of the places, the first object. Now you got 4 different places. Now also you got 4 different objects. So when you do that, you have, let's say, next one, suppose it is coming, you have 4 choices. So you got okay, let's say I've got 4. Now I'm left with 3 objects and 3 places. So what I'm going to do is I'm going to take, let's say, okay, next one which is coming will have 3 different ways. The next one, suppose, is gone, you got 2 more places left. So this one which is coming, you'll have 2 ways, and the last one obviously has to fit in any of the remaining place. So this is basically, if you see, is 5 factorial, or you can say 5 times 4 times 3 times 2 times 1 different ways. You can arrange these objects or letters in random ways, assuming that these are different objects. Now, when you talk about the, let's say, next part, which is sometimes you get on making the numbers or making the, arranging the letters and all. So what happens is there are 2 areas. When you see counting principle, there are 2 areas which I personally kind of categorize them. One is called the arrangement problems, generally. Arrangements, another is called selection. Now, the arrangement problems mainly belong to the permutation criteria, permutation part. And selection problem, like committee selection, or what you say is formation of teams, they mainly belong to combination. Now, what's the basic difference between permutation and combination? Now, the first difference that you notice is that permutation is actually where the order becomes important. Now, if I give you an example, let's say you're selecting, from 10 different people, you're selecting president, vice president, and a secretary, and where the order is important. So now, out of the 10 people, the first one to come will be the president, and then vice president, and then you select secretary. So your order is important. So in different, there'll be 9 or 10 different ways. Suppose out of 10 people you're picking up. So suppose there are 10 people. From here you're selecting 3 in a proper order. So it is nothing but 10 is the first person. Like suppose the president, for choice of president, I have 10 different choices. For vice president, now since I've selected one president already, you'll have 9 people left. So from there, you'll have 9 choices. And then after that, you have the secretary, which you'll have 8 choices. So actually, you have 10 times 9 times 8 as the choice. Here, the order was important. So when you're talking about the different number of ways, in this case, it is 10 times 9 times 8. So these will be different ways. You can choose a president, vice president, and secretary in a particular order. But what if I say that I want to just pick up 3 random people from a group of 10? And now this will be referred as 10p3. 10p3. Here 10p3 means from 10 people you're choosing 3 people, but in a particular order. This is what I can decode. And if you see, the definition of NPR is actually n factorial over n minus r factorial. So the definition is n factorial over n minus r factorial. If I do this, so from 10p3, it will be 10 factorial over 7 factorial. So it will be 10, 9, 8 times 7 factorial upon 7 factorial. So this get cancelled and you get the same answer. So here when you have a particular object or selection process in a proper order, your process is referred as a permutation. Now, what is difference between combination and permutation? So here in this case, if I would have selected, let's say, ABC, BCA, or CAB, and so on, you know. So like these are different orders. If these don't matter to me, the process become like a combination. Now, in this question, if this order was, for me, if this order was random, like I would have selected president, vice president in any random order. In that case, it's combination. Now you must know the formula for combination. So let's just take a combination formula. So what is combination is, from n different objects, if you are choosing R objects, then it is referred as NCR, or sometimes N choose R, N combination R. This is sometimes it is also written as N and R. So this means the same thing. So NCR is basically n factorial over n minus r factorial times r factorial. So this is, if you see the difference in the formula is here, this part is that there's an added r factorial here. So if I look at, in this case, it is, if I do the same problem, it will be 10C3 when there is no order being important. So when there is no order being important, the formula, this will be 10 factorial over 10 minus 3 factorial into 3 factorial. So 10 factorial upon 7 factorial times 3 factorial. So this is nothing but, if you look at, it is the same answer, which is 9, 10, 9, 8 upon, if you simplify this, it will be 3, 2, 1. So the only difference is that this 3 factorial, the division, 3 factorial is coming here because the number of combination. Now, earlier ABC was different. Earlier ABC, like president, vice president, and secretary, was being considered as a different, permutation. But for me, like when you look at in the combination, the result become 1/6 of the total number that you have were getting earlier. So when order is not important, you refer it as a combination. And remember that this case, this NCR is generally used for committee selection. And I'm going to take certain problems also that will help us understand this concept. So this is about the basic core difference between permutation and combination. Let us take some examples to kind of make and understand the particular part better. So now here's the first example about, we have to see where we use permutation and combination. So the first question that we see is, to calculate the number of different 6-digit numbers which can be formed using the digits 0 to 5 without replication or repetition, and assuming that a number which is 6-digit cannot begin with 0. Of course, that's the very basic thing. Okay, so now how do I understand and what will be the process to start this question? So let us say, when I'm talking about this question, the first thing that I look at is that, okay, highlight the key terms. So I want 6-digit numbers. So I'm going to place, let's say, 6 digits, 1, 2, 3, 4, 5, and 6. So these are the 6 places that I need to fill in order to make, or in order to get the question that is desired. Second is that the digits cannot be repeated. And third one is, a number cannot begin with 0. So generally, sometimes you'll not be given this thing in the question, and that is like a logical way to actually test whether you have understood what is like 6-digit or 5-digit difference between 6 and 5-digit numbers. Because once you begin a number with 0, it will not count the first digit. So like 0, 1, 2, 3 is actually 3-digit number, not 4. So if it is 1, 2, 3, 4, 1, 2, 3, 0, then it becomes 4-digit now. So start with 0 is always going to be a problem if you count the first digit to be significant. So now when you're talking about here formation of 6-digit numbers, so your first number has to be filled. Now this number, we are going to fill the first number. You're going to have 5 choices for that. So 1, 2, 3, and 4, and 5. So you're going to have 5 choices to fill the first number. Now let's say one of the number I have used. Suppose I used a 4. I could have used any number apart from 0. I have still left with 1, 2, 3, 4, and 5 numbers. So there are 5 more numbers that are left. So to fill in the next spaces, this I have 5 numbers. Then out of 5, one more is gone. Let's say I use 0, for example. Now remember, I can use 0 here. Any of these places can be filled with 0. Then for next place, you got 4, 3, 2, and 1. So actually, if you look at your answer, is 5 times 5 factorial. So this is basically the what you say is the different 6-digit numbers that can be formed with the given digits, and none of the digits will be repeated. Now I'm just altering the question. What if it is with repetition? If the problem was with repetition, in that case, you will have this digit, okay, you will have 5 choices for this digit, but for the remaining digits, I'm just going to redraw this. So I'm here, if you see, you got these 6 places to be filled. Now first, it has to be any of these digits. So 1, 2, 3, 4, or 5. So it has to be, let's say, I'm taking, for example, 5 different ways. Now, since I've used one of them, and I can use that digit also. So for this place, I'll have 6 choices. This has 6, 6, and 6. So you'll have 5 times 6 to the power 5 different ways to kind of do this problem. So you need to be very careful when you're reading the problems, like whether the digits can be repeated or not, whether the digits are like, if they're not repeated and you do repetition, you'll get 0 points for that. So that's about this kind of problem. Now I'm going to take the next one, which is basically here. So the next problem is a committee of 4 people is to be chosen from 4 women and 5 men. So here the question is that you're choosing a committee from 4 women and 5 men. So you're choosing the committee of 4 women and 5 men, and it's a 4 people committee. The committee must contain at least 1 woman. Calculate the number of different committees that you can form. So as I said in the beginning, that since this problem is about selection of committee, you're going to use the combination. So when I firstly look at what do I want is 4-member committee, number 1. And they have given the second constraint is at least 1 woman. Now, when I look at least 1 woman, firstly, I'm going to do one thing is I'm going to give some more examples to illustrate this question. Suppose I want, don't consider this question for now. Suppose from this given situation of 4 women and 5 men, I want to select a committee that contains exactly 3 men and 1 woman. 3 men and 1 woman. So when you're saying the 3 men and 1 woman, so from 5 men, I have to choose 3 men, and from 4 women, I have to choose 1. So as we know the combination principle, so from 5 men, you can choose 3 men in 5C3 ways, times you can choose from 4 women, you can choose 1 in 4C1. So 5C3 times 4C1. And you can find this out by using the formula, or if you wanted to do, you can just use a straightforward logic. From this number 3, you come to 3, 2, 1. So you always come till 1. So you go back 2 steps. Same way you go 5, 4, 3, 3. So you go back 2 steps from numerator as well. Here it is 4C1. 4C1 is going to be 4 itself, but 1 is already here. So 4C1 is 4. So this will be the different ways which will contain exactly 3 men and 1 woman. This I just wanted to illustrate you before taking to this problem. Now let's take the example is that I want to have at least one woman in the team or committee. So when I say at least one woman, so from 5 men and 4 women, at least one woman. So when I say at least one woman means it can be 1 woman and 3 men, or it can be 2 women and 2 men, or it can be, let's say, when I say it can be 3 women and 1 man, and it can be 4 women and 0 men. So these are the different possibilities. And remember that these are and 2 women and 2 men, 3 women and 1 man, and 4 women and 0 men. And then there is an or in between. So wherever there is an or, you always add. So this combination or this combination or this combination or this combination. So now put this on proper format. So 5 out of 4 women, I want to select 1. So it'd be 4 choose 1 times 5 choose 3 plus 4 choose 2 times 5 choose 2. Then 4 choose 3 times 5 choose 1, and 4 choose 4 times 5 choose 0. And of course, you're going to add these. So find out individual answers and you're going to add them up. So since I have got the answer already, now I'll just repeat again. This represents 1 woman and 3 men. So from 4 women, you're choosing 1 man or women. And from 5, you're choosing 3 men. From 4 here, you're choosing 2. And from 5, you're choosing 2. So it's like all of these committee selections will contain exactly at least 1 woman, and you have these 4 different combinations. So this is how you kind of do a little bit of committee selection based problems, and I hope this is helpful. So now we have got the next question, that is basically an examination paper contains 12 different questions, out of which 3 are on trigonometry, 4 are on algebra, and 5 are on calculus. So 12 in total there are 12 questions. 3 are on calculus, 3 are on trigonometry, 4 are from algebra, and 5 on calculus. So if I just write it down, let's say here, so it's 3 trigonometry, so trigo 3, then 4 algebra 4, and calculus 5. Now here what the candidate has to do is he has to attempt 8 questions. Find the number of different ways in which a candidate can select 8 questions if there are no restriction. So in this case, like out of 12 questions, if the person has to select any 8 question, it will be 12 choose 8. So 12 C8 will be the different, what you can say is the choices that he can make. Out of 12 questions, randomly 8 questions in any order will be the answer. Now here the next question is the number of these selection which contains questions on only 2 of the 3 topics. So 2 of the 3 topics, how can he select? Like, let's see the possibility. Okay, so now from he has to select 8 questions in total. Now let's say if he wants to select trigo and algebra. If he wants to select trigo and algebra, and because in total there are 7 questions. So how can he select 8 questions from there? So if you say trigo, there are 3 questions. Algebra, there are 4 questions. So he can't select 8 questions. So trigo and algebra combination, trigo and algebra, you will have like basically 0 possibility, 0 number of ways. Now if I pick up, let's say algebra and trigo and calculus. So trigo and calculus. So in total on trigo and calculus, you have got total of 8 questions, and out of 8 you have to attempt all of the 8 questions. So out of 8, to attempt 8 will be 8C8, which means one way. 8, choose 8. Out of 8, you're picking up all of the 8. That's one way. Now coming to this one, which has got now trigo and calculus, we taken care. Trigo and algebra, we have taken care. Now, if he wants to select algebra and calculus, so let's say if he selects algebra and calculus, so from algebra and calculus, you got total of 9 questions. There are 4 from algebra and 5 from calculus, so there are total 9 questions. So out of 9, so let's say algebra and calculus, so there will be 9C8, which is nothing but answer is 9 itself. So in total, you can, if you add them up, so you'll get total 10 different ways in which you can select 2 of the 3 topic questions. So this is how basically you kind of solve the question, which is linked up with like, these kind of concepts. Now let us take one more example, which is once again like, a very general example, but hopefully we can learn something from you. So the question here is, so a fashion magazine runs a competition which has got 8 photographs of dress are shown, lettered with A, B, C, D, E, F, and G, and H. So there are 8 photographs of the dresses are shown. Competitors are asked to submit an arrangement of 5 letters. So now the word arrangement is important, showing the choices in descending order of merit. So here automatically the order has become important, and the winner is picked up random from those competitions whose arrangements agrees with the chosen by the panel. Okay, the first question here is calculate the number of possible arrangements of 5 letters chosen from these 8. Now, since it is an arrangement, you see that it has to be in proper order. So like, which order, the first one I'm picking, whether I'm picking E or whether I'm picking H, the order will be important. So here, the answer for this question will be basically 8P8, 8P5. So from 8, you're choosing 5 in a proper order. So of course, you can work this out with 8 factorial over 3 factorial. NPR formula, n factorial over n minus r factorial. The second one, which you've got, is in which A is placed first, where A is placed first. So now since you're always keeping A in the first position, now A is coming here, let's say, which is, there's only one of the A letter, so that's one way. And now there are remaining 4, or remaining like, let's say 1, 2, 3, 4, 5, 6, 7. Let's say from here, what we got to do is, we got to put like, the 4 of them. Okay, so since already the first one I placed here in A, and now we have to, let's say, arrange them in, remaining of them can be basically placed in a proper order. So this will be basically now, since A is already gone, so we have how many choices left? Basically 7. So 7 for this, 6 for this, then you got, 5 for this, and 4 for this, and you can say 3 for this. So this is how you kind of do the second question basically. Or you could have done the same question, like since you already have one of the letter is gone, since it's like A has to be first, you have to choose 4 from remaining 7. So basically now this part is same as 7P4, or you could have written as 1 into 7P4. So that's how you kind of do this particular question. Now let's go to the next part, which is in which A is there, those arrangements where A is there. So what I can do is I can pick up, now think about it, like if I say arrangement of those letters must contain A. So what I can do is I can make, let's say, the random arrangements. I can take the, let's say, random arrangement, meaning out of 8 letters, I want to pick up all of them, whether it contains A or not. So 8P5 is the, from 8 letters, you want to pick up 5 randomly, whether it contains A or not. That's not gonna, this will be all inclusive. Minus, I can do the numbers without A or the letters without A. So now if I scrap out, I have got 7 remaining choices. So from 7, I can choose 7P5. So 8P5 minus 7P5 will be the answer for this particular question. I'm going to take one more question here to illustrate the permutation combination counting principle. So find out the number of possible arrangement of the single row netball photograph lineup in which Anushka, Beth, and Caroline are not next to each other. So let's say this is actually a follow-up question. There is a previous part to it. So let's first go to. Here the question is that, let's say Anushka, Beth, Caroline, Diana, Elizabeth, Freya, and Georgie line up for a netball team photo. Find out the number of possible arrangement in which Anushka and Beth are next to each other. So now these kind of questions you need to have, you need to learn, like, you know, a procedure. It's not, they're not hard, but if you don't know the procedure, you might find it difficult. So please understand the procedure. Now let's look at this. Let us say if I have got Diana, Elizabeth, Freya, Georgie, and let's say Caroline and Beth and Anushka. So there are in total, let's say 1, 2, 3, 4, 5, 6. There are 7 people. Now, Anushka and Beth are next to each other. It means that, let's say, if I consider, let's say Anushka and Beth, if I consider them like a single object, and remaining, you got like 5 people. So 1, 2, 3, 4, 5. Now they can change their positions. Okay, so they can change their positions. So what can happen is that I can treat them as a single object. So 1, 2, 3, 4, 5, and 6. So these 6 people can be shuffled among themselves in 6 factorial ways. So 6 factorial ways. And then Anushka and Beth can be also shuffled among themselves. So Anushka and Beth, if you shuffle, they'll be like 6 factorial times 2 factorial ways. So this is basically the answer to the first one. Second one, Anushka and Beth are not next to each other. So Anushka and Beth are not next to each other. So just think about it. If I consider all 7 of them randomly sitting, so let's say if you look at the random seating arrangement, so random seating arrangement will be 7 factorial. There is like any place they can go and sit, and then minus the ones with where they're together. So that is nothing but 6 factorial times 2 factorial, like which we just did for the part A. So that's the answer for the second question, where Anushka and Beth are next to each other. So this is a very common and interesting question. So if you think about it, just remember that, like generally this kind of questions are asked in like book arrangement on a shelf, those kind of questions you need to tackle with this particular skill. So now here, the question is a little kind of this one, which we were doing earlier. So the question is just a continuation of this, where find the number of possible arrangement that Anushka, Beth, and Caroline are not sitting next to each other. Okay, they're not next to each other. Now, what does it mean? Is that firstly, there are 7 people. So from 7 people, if I look at, so let's say from 7 people, I am picking up these 3 of them. Okay, Anushka, Beth, and Caroline. So remaining, there are 4 people. So first, make them stand. So 4 people stand in these positions. Let's say I have this drawn an extra space. Here, so 1, 2, 3, 4. And now we got, let's say, remaining people, apart from these 3, remaining people have to sit at these places. So like this is basically some random person, let's suppose here, 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 and here. Now we got to make sure that these three people are not sitting next to each other. It means that they can stand here, 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 or here. So remember that. Now firstly, these four people can be shuffled among themselves in 4 factorial ways. And not necessarily these places has to be occupied. Okay, so these four, let's say these three people can stand here, here, or here. These 2 places can be empty. So what has to be done is, out of the 7 places, 1, 2, 3, 4, and 5 places, we have to place 3 objects out there, or 3 people out there in an order. So that is nothing but 5p3, or you can say 5, 4, and 3. You can say that. So this is the net arrangement. You can see this is the answer 1440. That's in these arrangements, these people will not sit next to each other. Okay. Now this is the final example on the type of key concept that is required for our syllabus. So when you're talking about, let's say, the arrangements, now for example, I have got 2 exact same, let's say there are letters, I'm placing them, and there are like, or let's say consider some name. Now best way is like, let's say G-A-N-G-A-A, let's say Ganga. The letters of these you're shuffling, and you're creating a different kind of letters, like different random letters from these 6 letters. Now what might happen is that, see, if this is one possible way, okay, this is one possible arrangement. Now what happens is that if this G goes at this place, this still will be the same arrangement, or this A comes at this place, or this A comes at this place, the letter is still Ganga. So when there is a repetition or replication of the object, in that case, you just need to be a little careful. And once again, there's a procedure to it. Okay, so there are 6 different letters. If I consider that they are all different, I can arrange them in 6 factorial ways. And then there are, now out of this, you see how many are repeated and how many times they are repeated. So let's say I write G has been repeated 2 times and A has been repeated 3 times. So in this case, you just got to do one additional step, is just divide by this. So 2 factorial times 3 factorial. So these will be the number of different arrangements. These will not be the same arrangement. These will be the different arrangements of the letters. So let us say if I talk about, let's say, another one, AAA, PP, PCC. Let's say this is the letter. And I wanted to form, well, how many letters are there? They form different arrangements. So there are like 1, 2, 3, 4, 5, 6, 7, 8 letters. So first you're going to do is 8 factorial divided by, there are 1, 2, 3. So that's 3 factorial. Again, there are 3 P's, so 3 factorial, and there are 2 C's, so 2 factorial. So these will be the different letters you will form, which is not same as this one. So this is how you do the basic problems on permutation combination. And I hope all of these concepts help you.